to give us more information about the elements. It's something that they have done with almost every element. So the most accurate method currently available for comparing masses of atoms is using what's called a mass spectrometer. And this is found in your textbook. I stole the picture. But this huge setup over here, what this guy is doing, there's a big, in chemistry, the things that you use, they're machines, right? But we call them instruments, just like musical instruments and band. But these big testing instruments are what you use, and a mass spectrometer is one of those. And so it's a really huge thing, actually. But what happens is you put a sample, and usually it's in gas form, and if it's not, they vaporize it so that it is in gas form, and then it goes through, has electrons and ions so that you can watch what happens in between with the charges, and then it gives us a readout. So with this, they've analyzed carbon. So for example, we have isotopes carbon-12 and carbon-13 analyzed. The ratio of your masses was found to be 1.08 with more decimals. Using the definition of atomic mass unit, the mass of carbon-12, what we did to find the mass of carbon-13 was you can take 12 atomic mass units times this ratio number, and that gives you the atomic mass of the isotope of carbon-13. Okay? The masses of other atoms can be determined in a similar fashion. What we are going to do is we will actually be able to determine the atomic weight from data from this analysis. So sometimes on periodic tables, atomic mass is called atomic weight. On the old periodic table you got in Chem 1, that's what it said. If you look on the periodic table, the atomic masses given tend to not be a whole number, but instead decimals, because they are the average value reflecting of the isotope. Do you guys remember what an isotope is? I keep saying that word. Do you remember what that is? It's an isotope. Yeah. They have different numbers of which subatomic particle? Neutrons. Neutrons. Protons have to be the same, otherwise it's not the same element. Electrons only change when it isn't an ion. That's what you lose when it makes an ion. But the neutrons are what gives it different mass. So there's an average comprised of all of the isotopes to give that decimal number on the periodic table. Yesterday we had a americium in an example, and that was just a whole number. And that's because it's man-made, and we haven't found more than one isotope of that yet. So that's why that was a whole number. Okay? So this, I stole this from your textbook. This is a picture of what the output could look like from a mass spectrometer, where like this graph is all about neon, so they have a neon sign spelling neon. And then the B picture, and you have this in your notes, B is showing peaks that record the relative intensities of the mass number. And mass number, like when I say carbon-12, 12 is the mass number, the mass of the protons plus the neutrons. And then C is the output in a graph, a bar graph form. So the area under the peaks in the peak graph, the line graph, or the height of the bars will indicate the relative abundance of each isotope of neon. Anybody have a periodic table handy? I see some. What does it say is the atomic mass of neon on your periodic table? 20.18. Okay. What peak is the biggest? 20, right? And in here in the graph, the 20 mass number is 91% relative compared to all the other atoms. So 91% of the time, you will have the isotope of neon 20. Okay? But then like 0.3% of the time, it's isotope of with the mass number 21, and 9% of the time, the mass number 22. Okay? So the way that we figure out that it's 20.18, or whatever it was, you average these numbers with their mass numbers. Okay? We did this in Chem 1. We did. So we're just going to do it right now. When we have a sample of natural copper vaporized and injected into a mass spectrometer, the results shown in the graph are obtained. Use this data to compute the average mass of natural copper. and then the exact mass values are given. Sometimes you will be given exact mass values, and sometimes you won't be. So in this example, you are. So we are going to use this 62.93 instead of 63. This makes it a little bit more accurate. In Chem 1, I don't think I gave you exact numbers. I think I only just had to use the mass number from the isotope reading. Now, the way that we find this is called a weighted average. It's not like add them up and divide by 2 and that's going to be what it is. What we do is we use the relative percentage to multiply by the mass, and then you add each part together. Okay? So I don't really have an equation for it, but you take the mass, if you want to just write, I don't know if you need this or not. We're going to take the mass times the percent plus the mass of the other isotope times its percent abundance, and that will give you the average. That's what a weighted average does. Like for your grades in class, tests are 50%, homework is 5%. So whatever your grade is in harmony for your test, it takes it times 0.5 and then adds up each part together to get you your overall average for the grade that you see. Okay? That's how a weighted average goes. Okay. So and I don't know, do I have a slide? No, I don't. Okay. So we're going to take this is for, if you need to write this down, this is for copper 63. This is another way you could write it for the isotope. 62.93 times its relative abundance. Now, there's two ways to do it. You could multiply by 69.09 and multiply by 30.91, but you will be way too big, so then you would have to divide by 100. Or you can think about these as percentages and just move your decimal twice left and use the decimal form of the percent to multiply. I prefer use the decimal personally. So 62.93 times, and the 63 would be 0.6909 plus, now this is about the copper 65. So we have the mass is 64.93 times its percent in decimal form, 0.3091. Running out of room. Okay, so go ahead and solve for that. To write down each step before you add it together, that's fine. I do that sometimes. Especially if you aren't a parenthesis wizard in the calculator. Anybody have an answer? Courtney, what did you get?
63.55. And is it U or is it U?
It would be U. Because U is given as the mass unit in this problem, so we would keep it U for the unit. But we'll keep it 466, so. Alright. Okay. Whenever you're doing this average atomic mass for the isotopes, the way you check yourself is by looking at the periodic table. What does it say on the periodic table?
63.55.
63.55.
Well, we technically don't really have to do the.
I'm gonna give you a generic element X has all these masses, and then you have to tell me which element it is based on your average. So then you will have to do that. That's probably going to be a quiz question that you have. It was on the old quizzes, so I'll probably use one of those again, where you will have to do the math and then tell me which element it is based on that.
Because it has to match one of them, so if it doesn't match any of them.
Right. Exactly. So hopefully, if you need more help in this, let me know. But hopefully, even if you had chemistry 2 years ago, hopefully this math principle kind of thing